video is using the mole to find mass. The mass of 1 mole actually depends on the different elements or compounds you're looking at. It's expressed via the molar mass. Now, molar mass allows us to convert from mass to moles and vice versa. Molar mass is found the same way as the total mass of a molecule in our percent composition problems. The units on molar mass is grams per mole, written as G/mole. Let's go through an example. Example 1 says the molar mass of H2O2 is what? Hydrogen peroxide is H2O2. Well, first by determining how many of each atom I have. Well, I have hydrogens and oxygens. I have 2 hydrogens, each with a mass of 1.01. Multiplied together gives me 2.02. Oxygens, I have 2 oxygen atoms, each with a mass of 16.00 grams. So I get a total mass contribution of 32.00 grams. Adding them together, I get a molar mass of 34.02 grams per mole. Now let's calculate my molar mass of nitrogen dioxide. My 2 elements is nitrogen and oxygen. I have 1 nitrogen with a mass of 14.01 grams, gives me a contribution of 14.01. Oxygen, I have 2 of them, each with a mass of 16 grams, gives me a contribution of 32.00. Adding them together, I get 46.01 grams per mole as my molar mass of nitrogen dioxide. Go ahead now and try your practice problems. The answers are listed here. Now I'm going to use my mole to convert to mass in grams, using my molar mass to convert. This is the part of Mole Town where I am going from my mole center up to mass mole. To get there, I have to use my molar mass, which is expressed as grams per mole. I have to find my molar mass depending on what compound I'm given, using the masses listed on the periodic table. My example number 1 asks, how many grams are in 9.45 moles of dinitrogen trioxide? First, I always write what I'm given. I'm given 9.45 moles of dinitrogen trioxide. I'm asked to find my grams of dinitrogen trioxide. I want to know, what do I need to go from moles to grams? I'm in the center to the top. In order to do this, I need to find my molar mass of dinitrogen trioxide. My molar mass I find by using my nitrogen. I have 2 nitrogens with a mass of 14.01, gives me a contribution of 28.02. And I have 3 oxygens with a mass of 16 to give me a total mass of 48.00. Adding them together, I get a molar mass of dinitrogen trioxide of 76.02 grams per mole. This is my conversion factor I'm going to use to help me convert between moles and grams. Now I do my actual conversion. I start with what I'm given of 9.45 moles N2O3. I want to get rid of moles of nitrogen or dinitrogen trioxide, so you need to put 1 mole of dinitrogen trioxide on the bottom, canceling out moles. I know that for every 1 mole of N2O3, I have 76.02 grams of N2O3. This comes from my molar mass here. When I multiply my 2 numbers together, I get a final answer of 7.18 grams of dinitrogen trioxide. Example number 2 asks, how many moles are in 92.2 grams of iron 3 oxide? I am given my mass of iron 3 oxide to be 92.2 grams. I want to find how many moles I have. In order to do that, I need my molar mass of iron 3 oxide. Well, I have iron, 2 atoms of iron. Each atom of iron do is find my molar mass of iron 3 oxide. I have 2 atoms of iron, so 2 times my mass of iron, which is 55.85 grams, gives me a contribution of 111.7 grams. Oxygen, I have 3 atoms times my 16.00 grams, gives me a contribution of 48.0 grams. When I add them together, I get a molar mass of 159.7 grams per mole. This molar mass is what I will use to help me convert between grams and moles. So now I write starting with what I was given, 92.2 grams of Fe2O3. I want to get rid of grams and go to moles, so I write my grams on the bottom, my molar mass being 159.7 grams Fe2O3 for every 1 mole of Fe2O3. When I plug this into my calculator of 92.2 divided by 159.7, I get an answer of 0.577 moles Fe2O3. Go ahead now and try your practice problems numbers 1, 2, 3, and 4. The answers are listed here. Again, if you have questions on these, we'll go over these again in class, but it's best that you attempt them first by yourself. The last thing that my mole can do, it can help me convert between moles and volume. Now I can only do this for gas, where my 1 mole of gas is equal to 22.4 liters of gas, and only gas. That's thanks to Avogadro again. So example number 1. I want to convert 2.02 moles of nitrogen gas, a diatomic, to liters. I am given 2.02 moles of nitrogen gas, and I'm asked to find how many liters of nitrogen gas I have. To do this, I need to use my equation, or my conversion factor, to convert between moles and liters. Referring back to our mole town, this is going from mole center down to volume village. In order to do that, I must use my conversion of 1 mole of gas is equal to 22.4 liters of that gas. So I start by writing what I was given, 2.02 moles of nitrogen. I want to get rid of moles of nitrogen, so my 1 mole of nitrogen gas needs to go on the bottom, canceling out moles of nitrogen. And I have 22.4 liters of nitrogen as my conversion for every 1 mole. When I plug this in my calculator, I get 45.2 liters of nitrogen gas. Go ahead now and try converting between 12.4 liters of oxygen to moles. Start by